I have noticed again and again that American core and coil transformers like this one run very hot in Europe, and there's a reason for that. When I want to run them here on a 230 volt outlet, I can use a proper transformer to make 110 volts like this one, or I can use one of those cheap dimmer type thingies that don't really make 110 volts, but like a pulsating 230 volts, which is not very healthy for the sine. But what both of these cannot do is change the frequency. And Europe has 50 Hz while the US has 60. And that's a problem because the original transformers magnetics are designed for those American 60 Hz. And those transformers will have more internal losses and run hotter on 50. How much hotter is hard to say because they are all constructed a little different on the inside. But I have once written me down that it would be 20%. So you would basically either have to underload the transformer to compensate for that, or give it less primary voltage, however you want to do that. I got a new old American sine in, and again its Eggtown transformer was getting super hot, so I went to measuring, and here come the results. So that sine came with an Eggtown transformer American model for 60 Hz, made in 1988, as can be seen on the white date stamp on top of the Eggtown transformers. It's a 7.5 kV 30 milliamp nameplate, and it runs this specific sine at 26 milliamp measured and 85 lux brightness, while requiring 2.5 amp input with the mismatched 50 Hz frequency. And 2.5 amp is 133% of the nameplate rating, so yes, this transformer is absolutely overloaded. I cannot measure the power factor because my meter does not turn on at 110, but I could measure the temperature, which was almost 80 degrees Celsius, 170 Fahrenheit. So that is pretty hot for such a transformer, and the apparent power 300 VA. I found another Eggtown 60 Hz American model in my storage that is 2 years younger, and you see on those red arrows that they have changed their design. The cables are coming out at different positions, and apparently they have improved their product because this transformer gives me a bit more milliamps and a bit more brightness from the neon, but at the same time requires less power from the grid. We are only 23% above nameplate rating still. The case doesn't run as hot as the first one, and the apparent power is a bit lower but still pretty high. And I'm comparing the Eggtowns to a Technolux electronic transformer European model from 2010, so almost 14 years old, but still their current model. This is a 9020, which means 9000 volt maximum auto adjusting and 20 milliamp nominal current. European transformers usually have the nominal current on the nameplate, while American transformers put the maximum current on the nameplate. So the Technolux runs this specific Michelob sine at 23 milliamp with 76 lux of brightness, a bit less than the Eggtowns, but at the same time it requires much less power from the grid. We are within the specs with 80% of the input current from the nameplate, a very good power factor measured with 0.96, and the case temperature not to mention, and the apparent power is also much lower than the magnetic models. The comparable power I wrote at the bottom is because the Technolux has a bit less neon milliamps, so if it would have the 26 or 28 from the Eggtown, it would probably require around 80 VA. So yes, the result is it does absolutely make sense to replace a hot running, frequency mismatched American transformer for use in Europe with a new and modern electronic European transformer. The right one also has a ground fault shutdown and open secondary shutdown, while the older Eggtown models and other magnetic older models do not have that. So if the sine is not a problematic design like with a metal reflector or metal coated reflector like the light beer, or having very tight spacing between tubes, if it's just a regular sine with good spacings, then it's absolutely recommended to put a new transformer on there. Thanks for watching, hope to see you next time. Bye.